Well, thank you. Now I feel kind of idiotic. All right, I'll tell you what. I'll be right back. We're going to restart this again because everybody's missed everything that I've just said. So, thank you for that. And I can't believe I just did that. And we will try this again. This is the beauty of live television or online video or whatever you want to call it. All right, I'll be right back. We'll do take two in just a second. Hello everyone, and welcome to my live stream of machine learning with Unity machine learning agents. This is take two because, like an absolute rock star, I just spent 10 minutes talking to myself with my microphone off. Now, I know many of you are here because Suraj Raval did an intro, a very basic intro, to Unity machine learning agents. And while his overview is very good, he didn't actually go into what it takes to actually set one of these things up. So what I'm going to do is an end-to-end, very, very basic machine learning algorithm, right? So this thing should train live. We should be able to watch it train in just a couple thousand steps. It's only going to have one input parameter. It's only going to have one thing that it can really do, and it's going to do it really, really fast. But the whole idea is that it is going to do it, that we're going to do everything end-to-end live. So that said, I am going to go ahead, shrink my little window down here because that tends to get in the way. Oh, and if you are interested in doing Suraj's little weekly challenge, which you don't have a ton of time left because I think he has to have things in by Friday. But please, I'd love to see what people put up there. But Unity also has a challenge. They just completed the Neon Challenge, so you can see my submission for the Neon Challenge. I'm not an artist, so I'm very, very proud of the quality of the artwork that I did because I'm not an artist. But there are other challenges, and they have the ML Agents Challenge 1. There's only 14 people participating in this challenge. There's 13 days left, and I don't believe there's any prizes for this one, so this is just a fun challenge, but it is there. And so if you're going to put something together and submit it to Suraj, you might as well go ahead and just submit it to this challenge as well while you're at it. So what we're going to do is get going. So step one, of course, is going to be to download the machine learning code. So Unity Technologies ML Agents on GitHub, and I'm going to go ahead and download that as a zip. I'm downloading that as a zip. I already have a clone of this on my desktop, but I'm showing the end-to-end, which means I'm really starting from zero here. Okay. Going to start up Unity, and while I do that, I'm going to open up my downloads folder. Alright, and you can see my ML Agents master there, and let's see here on my desktop, I'm going to create a new folder, and I'm going to call it ML Agents Livestream. There it is. And I'll go into there. And go to my downloads, ML Agents Master 2. Okay, and then here's everything from the master branch of the machine learning agents. So I'm just going to copy that over. Now, if you're wondering to yourself if you're only seeing part of my screen, you are only seeing 1/4 of my screen. I dev it 4K. But I am going to try to do everything in this one quadrant. It allows me to have all my notes, and when you're working in Unity, having the extra screen real estate is super duper nice. So I'm going to go do a new project, and I'm going to call it ML Agents Livestream. There we go. I actually have 3 people watching. Hi, everybody. I don't know. I'm constantly amazed that anybody's actually interested in watching me do anything. All right, so this is the assets folder, and as I said, I unzipped things to my desktop, so we can do ML agents live stream. Here it is, Unity environment assets, and I'll just bring these over to my assets folder. Click on Unity, let it import. All right. Sorry about the tea. I normally don't drink while I'm on the air. However, I do have a cold. I was hoping to do this broadcast yesterday, but I was way too sick. My sore throat was not having it. So you're a day late and still get to listen to me slurping tea. Sorry. Okay. Let's save our scene. And we're just going to call this main. And we will go to our build settings, and we will add the open scene, which is why we just saved it, and we'll click on player settings. Now here in player settings, there's a few things that we want to do. First thing, get rid of the default as full screen. Our application will actually be managing its own resolution. We want to be able to run in the background. And those are the two biggies. Now, the other thing I'm going to do is come down to other settings and change the runtime version to experimental. I don't have to do that now, but if I hope to use TensorFlowSharp to actually run my agent in Unity, I'm going to need that in a little bit. So I move that over. There we go. And now we are in our space, and we're going to do some pretty standard Unity development to start off with. And again, this is going to be pretty boring, straightforward agent. We're not looking for anything super crazy going on here. I just want to be able to show all the steps you need to do to get a basic thing to go. All right, so first thing I'm going to do is create a cube, and I am going to put that at the origin, and I'm going to change the scale to 0.2 in the Y, because this is going to be our platform. All right, the position of that, I'm going to make -0.1 because that's half of 0.2, and that means that the top of this is 0, 0, 0 in relation to the world. And we will give this its own kind of local center in a little bit, but we'll deal with that in a second. All right, next thing we're going to do is create another cube, and not child that to the parent. Oops, oh well. And the scale on this is going to be 0.1, 0.1, 0.1, so we have a little cube, 1 centimeter on a side. This is going to be our floater. And then from here, we're also going to need a target. So I'm going to use a sphere because I'm super fancy. And again, I accidentally had it be the child of the floater, but that's okay. We're just going to choose scale 0.2, 0.2, 0.2, and we're going to put it at 2.1 on the Y, so it's kind of far up there. So we actually really need to get from here to there. Okay, that's all there is to that. We're going to move this back up. All right, and I am going to add a rigid body to this cube, which means that this cube is now susceptible to the unyielding forces of gravity. All right, so now if I hit play, bonk, that's it. That's all there is to it. Right, and then we're going to go ahead and move our camera closer so that we can see what's going on better. Bonk, great. Okay. So, next thing I'm going to do, I'm going to check this, and all right, we have a mesh renderer, and we have a sphere collider, and we have the sphere. That's great, that's all we need. So the collider means that this is also subject to the physics system, and this cube will hit this ball just like it hit that plate. Now these two, the target and the base, don't need rigid bodies. They can just have colliders, and that's fine because we just want them to hover there anyway. So they're not moving, they're just kind of existing in that space. So we're going to call this target. All right, so this cube, one of the other things we want to do is make the cube more visible, and that will help us when we're kind of monitoring our machine learning do stuff. So we're going to call this Floaters. Okay. We're going to go in here and we're going to create another folder for materials. And we're going to create a material. And we're going to call this red. And all we're doing is making sure that our little cube is visible from far away. That's it. So now we hit play. Bonk. Red cube on a white background. Easy to see. All right. So, and you know what? Just to make everything even more bleak, we're just going to change the background to black. That way we don't have anything kind of cluttering up our scene. We can see very clearly what's going on. Okay. Great. Next thing we need to do is we need to add a component. We're going to need a real quick script here that when something hits this sphere, that it reacts in some way. Right, so in the floaters, we're going to create a C# script, and we're just going to call that collision script. And I'm also going to create a folder for my scripts. All right, and then we're going to take this collision script, and we're going to just drag and drop it on there. We can see it's there. And again, we have the collider, and we're going to go into our collision script. Visual Studio will start up. Move Visual Studio so that everybody can see it once it's loaded here. There we go. And I don't care about starter update. What I do care about is public game object, floater object. Right, and then on collision, enter. Thank you, autocomplete. I love you too. Let's see here. If collision dot game object, I think that is the thing that is colliding, equals floater object. Then we want to do something. In this case, we haven't figured out what it is that we want to do yet. This is a prime time to use an event. So using Unity engine.events. And so now we will have a public Unity event, and we'll just do a parameterless one, and we will call this on collision. If on collision is not null, then we will invoke on collision. So basically, all this is saying is, if there's a collision and we collide with the thing that we want to collide with, we raise an event. And that's all it does. It doesn't do anything else. And so what's nice about this is it provides good separation of behaviors so that over time we can add a whole bunch of different things to it if we wanted to, that, it would cause an explosion and a particle system and a sound effect all at once, and that you can edit that in the Unity editor instead of having to write a script for each and every one of those things. At the same time, what I'm going to do, just for our own bug checking and sanity checks, we're going to say, we're going to create a public void collision test. All right, and this is just going to do debug.log bonk. Right, and so this is just going to make sure our collision works. Collisions are one of those things where that shouldn't be that hard, but so often I do see them having issues with it. Now, again, we're going to just reverse this for a second so that the sphere collider is underneath our cube so that we get a nice collision. So we have our target, right, and the floater object, that is going to be our floater, and then on collision the list is empty. And so we're going to add a reference to itself, and then there is in the collision script, right, this collision test. So what should happen, the box should fall, it should hit the sphere, and then the text bonk should show up in the console. And hopefully when I hit play, we won't find out that I'm total mudcakes. Bonk, sure enough, hey, it worked. All right, I love it when a plan comes together. All right, so I will move this back up to 2.1. All right, so the bottom of that is 2 meters above the top of the platform. Okay, and the reason why I know it's 2.1 is because the size of it is 0.2, and so it's half of the size. Okay, so that worked. So we can now get rid of this collision test, right? So now we have this on collision. We don't know what we're going to do when we're on collision, but that's actually where we will tell our machine learning system that, hey, our cube floated up and it touched the sphere, and now, you know, the system is done. We're done with our example, right? We have scored a 1. And we can be done. Okay, so the next thing we need to do is we need to go into our cube, and we need to be able, well, first thing that we want to do is when we come to the rigid body of this, constraints wasn't closed. Yeah, constraints was closed. It wasn't open. So what we want to do is we want to freeze this, because what can happen? We got really, really lucky because everything, my numbers were exact, and so like when I showed you in that last scene, the box hit the sphere exactly on top, super perfectly, and then it just stayed there. And a lot of times it's not what will happen. What we don't want to have happen is this box to hit the sphere, fly off somewhere, and then actually interrupt another part of our experiment. So we want to be really sure that we freeze the position and the rotation. So the only axis that this box can move on is the y-axis from the physics engine. So the physics engine will only affect this in the y direction, so it'll fall down or it'll float up, and that's it. All right. That is a pretty good start for that. So the next thing we need to be able to do is we need to be able to enact a force on the cube to make it float up. How much of a force? I don't know. I ran some early experiments. I think the number was 20, but I could have forgotten, so we'll find out. But what we're going to do here is we're going to add a new script. So we're going to go back to our scripts, and we are going to create a new C# script, and we will have this be, this will be our float script. And in our float script, we are going to need to know, let's see here. We're going to have a public float, maximum force, and so we're going to start that at 20. I think that's what worked when I did my earlier tests. And then we'll have a public float current normalized amount. So this is going to be a value between 0 and 1, right? 1 meaning all of whatever this maximum force is, and 0 meaning, well, 0, none of what this maximum force is. I don't think we need start, and we don't need update. What we do need, because we're doing machine learning, and this is an important note, because we're doing the machine learning stuff, we need fixed update. Because what happens is Unity actually accelerates everything in the machine learning agent's code. And so when it accelerates everything, if you use update, it's trying to do it based on frames as opposed to fixed update, which is at a lockstep with the physics engine. And so hopefully your physics engine doesn't break and everything happens the way that it should, and you're able to run at 100 times normal speed so that you can test things really, really, really quickly. So we're going to do public. All right, and I believe it's just fixed update. And my IntelliSense has broken. This is going to be fun. Public void fixed update. Right, and I believe that should just go. And so I'm going to check this and put my float in here, and so now I should get a bajillion bajillion messages. Sure enough, there's my fixed update. It says say test. There it is, saying test. Okay, I'm not sure what that error is or where it came from. Go ahead and clear that and just make sure this does exactly what it should again. Okay, great. And then, yeah, we're getting a bajillion of those test messages. All right, so in this case, a fixed update, what we're going to do is we are going to say, we do need a start. Public void start. Doing this without IntelliSense is lots of fun. Rigid body, my rigid body. My rigid body is equal to game object.get component rigid body. Yep. Nice try. Oop, that needs to be capital R though. Alright, if my rigid body is equal to null, then I do a bunch of stuff. Let's see, what things am I going to do? I am going to I'm going to take my rigid body, and then I'm going to add force, and I am going to add maximum force times current normalized amount. The other thing I'm going to do is I'm going to have a public void set force float amount. Current normalized amount is equal to amount. It's just a setter. Okay. Then we'll just use that in the future. Let's see here. Rigid body could not be found. Did I misspell it? Oh. Apparently rigid body is lowercase. Again, without IntelliSense, this is tough. Every now and then, IntelliSense breaks on this machine, and I don't know why. Add force needs to be a vector 3. That's fine. So we'll say new vector 3, then 0, that, and then 0. New problem. Okay. Okay, and so now what happens is I've hit play, that goes thunk onto the bottom, but then I can go to my floater, and I can say 0.1, nothing, 2, nothing, 4, 5. There it goes. And it gently floats up, and then hits the thing, and would say bunk, except for we turned off the thing where it says bunk. So, but our floater is floatering. This is kind of fun. Pardon me. This cold has been no fun at all. All right. So, we have a box. We have a target that we hit. We have a base that keeps everything in line. We have a working system that can be turned into a machine learning system. All right, so the next thing I'm going to do, I'm going to create another game object, and this is just going to be an empty game object, scale it to 1, and this is just going to be our environment. And we're going to take the platform, floater, and target, and we're going to put all of that in our environment if I knew how to drag and drop. Okay. Next thing we are going to need is, so now we're going to get into some of the machine learning-y parts. Thank you, by the way, for wishing me well. Let's see here. So we're going to do an academy. And we are going to add an academy to that. And let's see here. I think, well, it says Template Academy. I think we can actually just do a Basic Academy, because we don't need to do anything terribly interesting here. Now, when I said it was going to take control of the resolution at runtime, here it is, right? So here's training configuration, width and height. So this is the pixel resolution. So the idea is when it is training, it shrinks the window down really itty bitty to get maximum performance and not to tax your GPU. In inference configuration, this is when you're scratching your head going, what the F is going on with my system, right? Larger window, you can actually see what the heck is going on. So that's what that is about. And then default reset parameters, if your Academy, if your system needs to do anything to reset, that's where that goes. In our case, we want to give a time limit. We have a task float from the bottom to the top. Every second that you don't do that, we're going to penalize you. And if you do that, then we reward you. But we're also putting a max time on it because we don't want you floating around pointlessly until the end of time. So we're going to say the max steps is 1,000, right? That's it. That's all you get. You get 1,000 frames. And that's, if you don't complete by then you get a negative score because you haven't gotten anything accomplished, right? So that's our Academy. And then we're also going to create a brain. And this is just going to be our default brain. There's nothing very fancy about this brain. There's certainly nothing fancy about my brain. All right. There are three types of brains, right? There's the player, there's the heuristic, and there's the external. There's also the internal, but that's not actually going to show up yet. Player means that a human is going to be playing the game. Heuristic means that you have some algorithm that is going to play the game for you. And then external is what you use when you want to train the darn thing. So we're going to start with player. And the reason why we're going to start with player is you should always be able to play your own game and beat your game. If you are unable to do it, then your machine doesn't really have much of a chance, at least to start. Okay, so we're going to have one action. There's only one thing that you can do as the player. That is hit the space bar. That's it. That's all you're going to do. And then that is going to have a value of 0. Oh, yes, that is... Sorry. Oh. We did forget to do something. Okay, so I want this to have a value of 0.6. Right now, though, it's only taking an integer value. And that is because we are in a discrete space, and I want to be in a continuous space. Discrete space is okay for many projects and problems. I honestly find that the continuous space allows you a lot more flexibility, a lot higher dimensionality. So, let's go ahead and change this. Let's go back to the Academy. And this Academy might only be designed for discrete, so I might have to change that. Or no, here it is. It's in the brain parameters. Action space type, that is going to be continuous. So discrete is basically saying you just have a number that you input as a value, and so you literally enumerate every single action that you can take. And it doesn't take a whole lot of that before it gets really complex, because if you're like, I want to go up or down, you know, okay, 1 for up, 2 for down. Now I want to go left and right, and so it's up and down, and then left and then right. But then is it like also including up, right, up, left, down, right? You know, you start getting the, you know, the Cartesian product of all the dimensions. So continuous just basically says I have one value for up, one value for left, and then you usually like a negative left is a right, and a negative up is a down. So continuous, I think, provides a lot more flexibility. So continuous player actions, there we go. One continuous player action, again, if I press space, it's on here somewhere. Come on. There it is. Right, I want index 0, action 0, to have a value of 0.6. So basically, I'm just going to do something at 0.6 power, as opposed to full 1 power, which is a little overkill for this little example. All right. So we haven't bound that value to anything yet, so we're going to have to start getting into that. Okay, so in our environment, we're going to need 3 main scripts, right? Well, one is the Academy, although we had the simple Academy, and so I think we're going to be able to just reuse that one carte blanche. So we may not have to actually author. Ooh, hold on. An Academy, which is nice. You could, but for a lot of problems, you don't need to. And so we need an agent and a decision, right? So a decision is the machine, giving your machine the opportunity to do something, right? In this case, our decision state space is only 1, so we need to make sure all of that lines up. And then we need our agent that is going to kind of tell us when we've done something right or wrong, you know, when we're complete or when we're still working. So let's go ahead and create a folder in here, and we're just going to call this ML, and we're going to create a floater agent. Now, instead of writing this agent from scratch, what we're going to do is there is a template in ML agents, right? Template scripts, template agent. And we're just going to pop that open, reload, and we're going to copy that. Right, we're going to copy all this, and it's important that we get that the class is an agent. Right, we're going to copy this, and then go to our ML script, and just going to paste that puppy right on in there. Make sure you get rid of that extra colon, because our parser won't like that. All right. So collect state. This function is very important. So this is providing evidence to the machine learning system what is going on in the world, right? So this becomes very, very important. So we're going to want to collect a few things. We're going to want to collect the position of the target and the position of our floater. So first of all, we're going to need references to those. So we're going to say public game object target, public game object floater. Okay. And so we're going to do state.add, and we'll go floater. Come on, IntelliSense. Floater dot transform position dot y. Hopefully. Boy, I really didn't like it when I copied and pasted it. The indenting on this is all jacked up. All right, we'll survive. And then the same thing that we're going to do is we're going to add the target transform position.y. And we're going to go back to Unity and see if Unity hates me because I got some capitalization or something wrong, because IntelliSense is being a pain in the butt. Nope. Okay, good. So what we're going to do is, in our environment, I'm going to go ahead and create an empty object, and I'm just going to call this ML dash manager, right? And agent. So for this, we're going to call this, grab our floater agent, right? Okay. So our agent, every agent has to be associated with a brain, all right? Brain. Maximum steps. In this case, was set in the Academy, so I don't think we need to set that. Reset on done is true. The target, that is going to be this jobber, and our floater is going to be that jobber. All right. Let's go ahead and go back to floater agent. So this should be getting all of the things that it needs to know about our scene. Now, agent step. This is our agent's chance to act, agent's chance to do something. So this action, it's an array of floats, and so that's basically, again, our parameters. Now, if you're creating a more advanced machine learning system, you're going to want to enumerate or do something to keep all of your float indices and actions straight, because it's easy to get them confused, because at this point we're basically talking about magic numbers, right? That you're arbitrarily saying that float, 4 of this act array is your uppiness of your value, or whatever it is. That gets confusing, so I highly recommend creating an enumerator to help keep all that straight. However, we only have one item in this particular array, so it's a very short array, and so we know that float, which is to say we're just var float amount is equal to act 0. All right. So we know we only have one possible action. Our array is of length 1. I told you this was going to be simple. But there it is. So next thing we're going to do is we are going to take this, and then we are going to invoke that set value, right? That, remember we wrote that setter in our float script here, this set force. Yeah, not terribly well named, but that's fine. So, you know what, just in the interest of keeping this simple, we're going to do public floater script. I know this is actually bad form, but it's super convenient. And so now we'll go back to our ML manager and we'll have our floater. Great. So then we can just do floater script dot set. What do we call that? Set force. There we go. All right. Now, again, this is the general structure I use where I get everything here. Oh, I didn't clamp it. Mount is equal to mathf dot clamp float amount and then 0 to 1. So this is just a min-max. Make sure that the float amount is between 0 and 1. All right, and again, I'm going to go back to here, make sure I don't get any syntax errors. Clamp with the capital C. Clamp with a capital C. All right. All right. And then agent. This agent is expecting a brain with a certain size. I don't know if we have all that set up yet. All right, so we have our academy, we have our brain, we have our ML manager, that has a brain. We have our target, we have our floater, and we have our float, and we can press the space bar, and that should do something. Oh, number of states does not match for ML manager. Was expecting 1 continuous states, but received 2. Yes, because we were passing in 2 parameters. We're passing in where this is and where the target is. So we should get brain. State size is 1. State size should be 2. 1 for the floater, 1 for the target, and then the action size is 1. So we can only ever move in 1 dimension. There it is. Okay, let's try this again. There it is. Okay, beautiful. And then I press space, and it floats up, and then boom, it touches. Now, notice it doesn't do anything terribly remarkable when it touches. That's because we haven't set the end condition yet, but we have all the hooks for that in place. So, let's see. Let's go back to our script here. All right. Collect reward. All right, so this is in our... This is in a default agent. Okay. But we need our floater agent. Agent reset. So what do we do? I want to set the target, transform position dot y equals to 0.1. No, I don't want to do that. You know what? I'm going to bring it up a little more. Okay. And then we don't need to do anything on done. I don't think. All right. So that's all we need to do when we reset is we need to move the box back to the middle of the darn thing. All right, so now what do we need? We need a decision. And so again, Unity provides us in their ML agents code, they have examples, template, scripts, and here is their decision. Right, and again, this is pretty simple beastie, so I'm just going to copy all this. Now, one of the things that we need to keep in mind is that the number of floats that we return here should be the same as the action space. Right, and then the make memory, in this case, I'm not even bothering with memory, so we're not even going to go there. All right, so let's go ahead and go back to our code, and we'll go to floaters, scripts, ML, create, C#, and floater decision. And we'll just copy that, change the name back, and I believe that needs to be the same space, the same size. Right. I don't think we actually have to do anything else here. Target.transform.position. Excuse me. All right. What are you complaining about, Unity? Oh, can't modify. Okay. Got it. All right. So it's saying I just can't modify the position. Why? And actually, what we need to do, this goes new vector 3. Well, yeah, vector 3, and we'll do transform position dot x, transform position dot y plus 0.5, and then transform dot position dot z. All right, so that is putting everything relative to the agent. Right, and so this is just saying when we reset 1/2 a meter above the origin of the agent. And which actually reminds me, all of our other code is in world space as opposed to relative space. So we're going to need to fix that real quick. Not hard to do at all. All right. So it's just when we are here and we're adding the floater transform states that we actually need to do transform position dot y minus no. Take that, reverse it. Right. Take the floater's position and remove our y position so that again I can move this environment around, or what I will be doing is duplicating it and have multiple of them, and that they're all in the local space as opposed to the global space. All right, and then, oh, and somewhere along the line I destroyed my closing bracket. Compiler should be much happier with that. Yep. Okay. Let's see here. Uh-oh. Unity? Alright, everything else seems to be working. Oh, there it is. My Unity. Alright, saving my project just in case. Alright, what now do we need to do? We have our academy, we have our decision, we have our input, we have our output. We need to finish our... we need to be able to add a reward, and we need to be able to say that we have reached the end condition. So that should be in here, that we add the reward, I think. So I'm going to go ahead. All right. Okay, so we're collecting the state. All right, and so we're going to have a... we need to be able to announce to the world that we are done. So we're going to do public, void, and target reached. Now, we're going to do two things in here. In a lot of cases, you don't do them in tandem, but for our very simple example, we're going to do them in tandem, which is going to be reward plus equals 1, right? And so the reward is just a property of the agent. And then we're also going to set done equal to, whoop, no, not agent on done, just done. Stop it, IntelliSense. Done is equal to true. Again, done is a property of agent. So the idea here is that we're just adding a reward, and then we're telling the system that we are done. The other thing we wanted to do, so we could parameterize reward, and you know what, we probably should. So let's go ahead, public float reward amount. So we'll just start with 1. We'll see how that does. That should be enough. That's normally where you try to normalize the values. And then we'll also have public float per step penalty. And so when I tested this earlier, 0.02 was a pretty good place to do this. So we will also have a public void. No, we don't need to do that. We already have an agent step. So in our agent step, we're going to do reward, right? Yes. Minus equals per step penalty. Yes. Yes, yes, yes. You know what? There's a way cleaner way to do this, by the way. I'm just going to do this. So I'm going to reset the position. I'm going to do transform dot position plus new vector 3 0 0.5f 0. Yeah. So my position at half. All right. So now we have a public void target reached. We increase the reward, and that we say that we are done. We have our collect state, which gets the relative y location of the floater and the target. We have the agent step, which adds the force and subtracts a per step penalty because we want to reach that target as fast as we can. The agent reset resets the position back close to where we started from. And let's make sure that our very first one also starts at the same place so that it's repeatable and consistent, that we're providing consistent rewards. Because if we start it right at the top, it's going to get there faster, and therefore the first run would always get a better score. So we want to make sure that we are very consistent. I do actually think, to prevent that, that the system does, at the very first initializer, runs that reset code just to prevent those kinds of initialization errors. I'm not 100% sure on that, though. Oh heavens. All right. Let's see here. Oh, we have a compiler error. Oh, we don't have a reward amount. Let's see here. There it is. Okay. Just an errant F. All right. All right, so our reward amount is 1, and our per step penalty is 0.2. And now, if I play this with luck, oh, that's odd. Oh, I moved the target, not the floater. When I reset, and see it does run this code because it moved our target, and when it should have been moving our floater. Okay, so now, when I hit play, there we go. Boom. We hit it, and again, we just need to tie the events. We just go over here, floater, and we say, we make a call back to the manager, and we call the floater agent, and target reached. That's what we call it, right? Target reached. Okay. That should be it. Bonk. All right, and we hit it, and then it resets, and we're still holding space, and so it continues to go up. But what's happening is, you'll see we hit it, it resets, and that's great. If we float here for a while, I don't know how long 1,000 steps is, so we're going to have to kind of oh, there it is. Right, you'll see it automatically kind of reset on its own. And that's the Academy saying, your time has expired, you're done, dude. And so to get that to do it again, just so that we're really confident, we should see, yep, there it is, and then again, we can go up and bonk it. So that's great. We are able to play our game works, our machine should now be able to play the game as well. Okay. All right. Now we have a machine learning algorithm that appears to do the thing. Let's set this up so that we can go train it. So one of the first things we're going to need to do is actually, and I do this every single time, I go ahead and I prefab this environment out. All right, so now we have this environment and we're set. And then we delete it because we have it prefabbed out. The reason why we're prefabbing this out is because the machine learning code that Unity has provided is able to train more than one environment at a time. So we can actually have it run multiple scenarios. So we can get a 20 times speed up by having 20 environments running at once. There have historically been some issues that if you have more than 20 environments, that the whole system will crash, that it doesn't initialize right. So play with those higher numbers at your own risk, but 20 is usually a pretty reliable thing to have. So in this case, we're going to just have an environment duplicator script. And so the easiest thing to do is to just, and we're going to cheat on this one because the code already exists. And we're going to go to GitHub, and we're going to go to my GitHub. And this is all public, so you can do this as easily as I can. And I will also try to make this code available. Here's my ML agents, and oh, let's see here. Yeah, okay, it is an ML agents. And where is the search environment? Really? Nothing? Alright, I'm not convinced. ML agents, examples, and let's see here. I know one of these has it. And I'll make sure, I'm going to upload this to GitHub as well and make a package out of it at least, so that everybody can just get this a little more easily. Okay, that's from there. Let's see here. Environment duplicator. Really? I am kind of surprised by that. All right, well, that's fine. I know how to write this. It's not that hard. And so this will actually make sure that we have one handy dandy and ready to go. Environment duplicator, and we will, yeah, we'll put that in the ML stuff because it's ML related. All right. All right. So we want a public int rows, and so we're going to say 4 rows, public int calls, 5 columns, and public game object prefab. That's the thing that we're going to reproduce. And public float call spacing is equal to 2. Public float row spacing is equal to 2. Actually, I know we have multiple rows going on here, and that each one's a little over 2, so I'm going to make that 2.5. And then, so the only downside of duplicating the environment is our environment is prefabbed, but our brain is not. And so we're going to need to reassociate the brain with the prefab. So we're going to need to do public brain to use, I don't want variable names like that. And then we're going to do this in awake as opposed to start. So this is actually a little earlier in the initialization. And then we're going to do count is equal to 1. And vector 3 cursor is equal to new vector, actually vector 2, because we only really need x and y. Because we're not placing things in the z, we're not stacking them back. And we're going to say column spacing times calls. Call spacing. Call spacing times calls. Times negative 0.5f. So we're going to take the columns times the column spacing, and then we're going to just shift everything halfway that way. And then we're going to do the same thing with row spacing. Row spacing times rows times negative 0.5f. Okay. And cur is not going to do it. Neither is cursor. Yeah, cursor. All right, for var is y is equal to 0, y is less than rows, y plus plus, and then for var x is equal to 0, x is less than calls, x plus plus. Classic stuff. All right, and then we're going to say var and v is equal to instantiate game object of prefab, and then we're going to put it at the placement cursor. The rotation is going to be quaternion.identity, and the parent transform is going to be this object, so that it's all nice in the hierarchy. All right. Environment name is equal to count. That's fine. We'll just say environment plus count. Count plus plus. Let's see here. So I need the brain. I need to get the agent. So the agent script is going to be the environment.getComponent agent. Nope. That agent script. Stop fighting me, IntelliSense. I know what I want to do. Agent script dot give brain to use. Thank you. And then placement cursor dot x column spacing, call spacing. Right. And then after each loop, we are going to do this again. All right, we're going to reset the x, so placement, cursor, just cursor. Cursor dot x is equal to that, and then cursor dot y, add row spacing. That should be it. So basically we just character turn down, go back, and now we're doing this. Great. So now we're going to create an empty, call it environments. We are going to try to move this environment script over, see what crashes. Nothing. Wow. Hey, I like it. All right. Our prefab is our environment. The brain to use is going to be this brain. So now I'm going to go ahead and switch the brain back. Oh, it's okay. It's still in player. So now when I hit play, the whole thing crashes. All right. Brain to use. I could have sworn I dragged brain in there. Brain. That's the brain to use. Agent script. Get component in children. Try that. Right, because it's not at the top level, it's a little further down, so you need to get component in children instead of get component. Now try it. There we go. All right, so I'm going to back up in the scene here and just do the sanity check. All right, so we have the target, we have our thing, and there. And then the next target, there's a little bit of space between all of them. So we're able to see a whole bunch. And so I'm going to go ahead and I'm going to click on my main camera. I'm going to set it there and copy that transform. Go back to my game, press space, and all of a sudden I'm playing 20 games at once. I am a super ninja, or at least somebody who can press the space bar. So there's that. Okay. All right. We are rocking and rolling here. All right. The last thing we need to do is go ahead and change our brain type to external, because we're not going to bother with heuristic at all. We're going to change that to external. We're going to build this. Build. And we are going to go to the desktop. And somewhere on here there is ML live stream. There we go. And I'm just actually going to dump it in the Python. Yep. Okay. And we'll do floater -20. I like putting the 20 in there so that I know that this has 20 instances. So while that builds, I'm going to go blow my nose. I'll be right back. Looks like we've built. Wonderful. And again, I do apologize for doing this with a cold, but I know that a lot of folks are trying to work on their projects for Suraj's thing by Friday. So if it weren't for that, I really wouldn't be doing this. Okay. All right, so we have our floater.exe, and for some reason it came up with the resolution select screen, so I'm going to go into the player settings again and check my resolution presentation because, okay, and here it is. Display resolution dialog, that should be disabled. We don't want to do that. We do want to run in background, and we don't want to default to flat screen, full screen. All right, build. Replace what we just did. All right. Now we get into the machine learning parts. And this is where there's always the chance of machine restarts and that kind of thing. All right, the first thing we need to do is start all of the machine learning stuff. I actually have a handy-dandy startup batch file that I use. There's not a lot in this, and so I will just show it to everybody. Right, so this starts up Jupyter, it starts up TensorBoard, and it opens up a connection to TensorBoard. Jupyter, when you start Jupyter, automatically opens up a tab to that. So I'm just going to fire up my startup batch file. All right. And it can't find my TensorBoard. This is the very first time we're starting it up. So it gives it a second. There we go. Hit enter and it fires up. We're in Jupyter. We're going to go into Python and we're going to use the basics Py notebook. And we are going to grab the name of our executable. Which is floater20. I'm going to put that there, save it, and then we should be able to run this whole kit and caboodle. Oh, heavens. Everything's gray and loading. All right, the Academy started successfully. It really wanted to go full screen. It's just a full screen window. That's fine. Because as soon as I start it up, right, it should go. All right, so the agent state, this is the starting position, right? 0.5, that's where our floater starts, and 2.1 is where our target is. That's great. And then we should be able to take random actions. And as soon as it does that, it gets itty bitty. Right, here it is. Oh, I can't even move it. It's so small. The window, it's itty bitty. 80 pixels by 80 pixels. All right, it takes a bunch of random actions and does terribly. Right, total reward this episode was -19.97. Now, I am a little suspicious. Because these are all the exact same value, that means that no point in time did any of these 10 randomly touch the top, which means that it might need a little more oomph. All right, well, but we'll at least be able to close it. So we should know really quickly when we train it whether or not it's going to train up or not. So we're going to leave this. All right, and then here, the run path. It's fine. Environment summary frequency. I want an update every 100. You would never do this for an actual real machine learning problem. However, ours is kind of stupid simple, and therefore we're going to do it at 100. Let's see here. Everything else looks like it's pretty good. Now, this is also the moment of truth where we find out, oh, close Unity. Close Unity. I don't know about your GPU, but my Python TensorFlow setup hates it when anything else is using my graphics card. So turn off everything else that might be using the graphics card. And I'm going to just turn off as much as I can. All right, I'm going to move that one out of the way because I'm going to need that in a minute. All right. So we're going to run NumPy. Set our hyperparameters. We're just using the default hyperparameters because our problem is just that dumb. We're going to load the environment, and it loads. I can see the little itty-bitty window. I can't even get it to show. It's so small. It's this tiny little corner down here. I don't even know if it's broadcasting. Yeah, you can see it. Just the Unity symbol. It's not a whole lot bigger than that. All right. So that is going, and then so now we hit train the agents, and we'll go over to TensorBoard, and we will reload TensorBoard, and we will reload TensorBoard again, and we will wonder if this is actually doing what it needs to be doing. Oh, let's see here. That's for the Jupyter Notebook. That's for TensorBoard. And we don't appear to be generating any actual data. Oh no, here we go. All right, so we're getting output. We're not getting it in TensorBoard for some reason. So step 1000. Right, it was doing terrible. And then somewhere in here, it held down the button long enough to get going. And our rewards have gotten better and better and better. And so now it is continuing to learn. So step 6700, it's getting a score of 0.5. That might be about as good as it gets, depending on our force level and the amount of time. Maybe not, though. And if you look and see very carefully, you can see just a little dots moving around. I really wish I could move this away from the center of my screen. But you can see there's a tiny little something right down there. It's the red squares are like 1 pixel big. And so now we're seeing a mean reward up. And it's figured out something here, or it just got lucky, or there was a bug or something. Because that reward is suspiciously... Oh no, that's low. Yeah, so it's just trying something else out. Yep, it's trying different values, seeing if it can get better rewards. So here we are, 11,000 steps in, and it's already pretty much figured out how to solve this problem. I don't know why it's not saving to the TensorBoard, though. I didn't have that problem yesterday, but you can see it continues to do its thing. And so it's training. Sometimes this does better, sometimes it does worse. It's, experimenting with different values. And then every, I forget, what is it, 50,000? Yeah, every 50,000 it saves a version of the model. Okay, so this has gotten all gunked up. It's really hard to read. But it continues to succeed, and so we are at 21,800-ish. Again, it seems to be looping in some strange way. I'm not sure what's up with this. Jupyter, I'm sure there's just like a maximum buffer and it's just looping. But it's working. So while it works, I want to look up one more thing, and I can never remember this specific magic keyword, so we're going to go to the ML agents documentation. ML agents, docs, and let's see here. Here we go. How to use TensorFlowSharp inside of Unity. We've already set the runtime to be the proper runtime. We have the right version of Unity. Oh, that's new. Hope that's not super important. Okay. Enable TensorFlow. There it is. So we will need to do that in the player settings once we are trained up. Of course, with this clogged up, maybe we shouldn't have been reporting every 100. It is impossible for me to see what is going on in there. However, what I can do is go to ML Agents live stream, go into Python, go into PPO, whoops, models, PPO. Okay, nothing is saved yet, so we haven't hit 50,000. It should only take another couple of minutes to hit 50,000. Summaries, PPO. There's definitely data there for TensorBoard to pick up. I don't know why TensorBoard hasn't. I'm going to actually restart TensorBoard. PowerShell. Oh, come on. There it is. Should be able to close that now. Apparently TensorBoard does not love me today. I don't know why that is, because normally you can usually monitor that. I may have just started it in the wrong path or something. Alright. Okay, so what we're going to do here, we're going to wait for this to finish. We're going to go get the bytes file. We're going to bring the bytes file back. And then once we have the bytes file, we can actually run the trained network inside Unity. And then we have completed our end-to-end. Ugh, models. Ah, there we go. Highlighting it helped. Saved model. All right. Checkpoint. Model saved. Excellent. Excuse me. All right, so I'm going to stop that, and then I'm going to export. All right, and so there's our 50,000 checkpoint. And it froze 7 variables, and now here is our floater20.bytes file. That is what we need. Thank you, machine learning-y stuff. And it actually worked the first time. I didn't even have to restart my machine. I'm super thrilled. All right, let's fire up Unity again. And then we are going to go to our build settings and go to our player settings, other settings, enable TensorFlow. Should be able to save that. Okay. So now that we've enabled TensorFlow, a bunch of stuff doesn't work, right? And that is because we don't have TensorFlowSharp, so we need to get TensorFlowSharp. So, and again, the best resource for this is to just go to the ML Agents docs and then go into this experimental, download here. There we are. It's downloading the Unity package. And so, assets, import package, custom package, downloads. Today. There we go. There we go. Whole bunch of DLLs and stuff. And this is why you had to set that runtime the runtime environment variable that we set at the very beginning of this episode, because otherwise this portion would not work. All right. Now, that has taken care of those errors. Now we can go to our Academy. I'm sorry, yes, and open that up and go to our brain. And then internal brain. Yay! All right. And floaters. So here we have our floater. So now we just need that bytes file. So we're just going to grab this floater 20 bytes. Let's see here. Graph model. There it is. Graph placeholders 1. Epsilon. I believe that's supposed to be a float. And 0. Double check the docs. Uh-oh. Do we no longer need to set epsilon? Placeholders. Huh. All right, this has changed. It used to be that I had to set a placeholder with a name of epsilon and a value of 0, so I'm a little concerned that none of this will work. Oh, no, it works. Look at that. Here's our machine playing our game, as dumb as it is, on its own, with its own brain, that we have trained. It works. So, what is this particular problem good for? Not a whole lot, but it does mean that in about an hour and a half, we have done an end-to-end. We have gone through all of the steps. We've been able to train something. We have been able to get it to go. And even while sick, and sorry to say, slightly disgusting. Sorry about that, folks. So, I hope this is really helpful, especially for those of you that are working on Siraj's challenge, which is due Friday, and then again, 2 weeks from now-ish, I think it's 13 days, is the Unity Machine Learning Agents Challenge, which you can also submit things to. So, thank you all for watching, tuning in, and helping out, and letting me know when I was being especially disgusting. I am so very sorry about that, but I figured you'd rather have the information now than after it was useful. So have a wonderful night, and I will see you guys in a week or two when I start up my next project. Thanks a lot, and take care.